All right, guys, we just have a little bit to finish today, and then you'll have time to work on homework, try to finish the chapter review, which is due tomorrow, and then IXLs are also due tomorrow. So we'll have some time that you can get a lot of work done today if you need it. All right, so last part, we worked on Friday on adding and subtracting with I, but we never really talked about multiplying with I. We did with radicals, but we kind of left off with the i's. So first and foremost, you have to remember that I squared equals -1. You got to know that. So we have to memorize that I squared is -1. So anytime you see an I squared, it's considered, bless you, not simplified. So if we would multiply, right, we treat I just like a variable. So distributing here would give us -10I. Distribute here gives me -2I squared, right? I times I is I squared. So if you see an I squared, it's not simplified. So we know that I squared is -1. So I can actually rewrite this. And instead of I squared, I can replace that with -1. Because that's what I squared is equal to. So what's -2 times -1? Good. There'll just be a +2. And then I am finished. So what's really happening, anytime you have an I squared, what's it doing to the sign of whatever it's attached to? What if it was already positive? It would flip it, yeah. Yep, multiplying by a negative sign, it's just going to flip whatever sign you have. Okay? But I just wanted you to see clearly where that's coming from. It's because I squared is equal to -1. Right? Oh, that would have been in the video the day I wasn't here. Right? Because we know I is the square root of -1. Right? That's how we simplify radicals with a negative. So then if you would square both sides, right? I squared. What do you know about a square and a square root? What are they to each other? They're opposites. If they're opposites, they cancel each other out. Right? That's where I squared is -1 comes from. Okay? All right, so down here, I just have 7I times 3I. So it'd be 21, and then I times I is I squared. Well, we know I squared is -1, so that would make that -21. No. I just want to make sure everybody knows what I'm doing. If you're comfortable, be like, oh yeah, and just switch it to that, that's fine. Now, what I do see a lot is people like, oh yeah, we know I squared switches it, so then they write -21 I squared. No, I squared is the -1, so the I is completely gone then, because you've replaced that. All right, so we'll just get in a little bit more practice in here. We have, going to distribute -3 times 4. It's -12. -3 times -2I. Let's say +6I. And then distribute this way. 6I times 4 is 24I. 6I times -2I is -12, and then I squared. The mistake students make a lot of times is they forget to write I squared, and they write just I. And then they don't switch a sign, and then they put like terms together that shouldn't go together, and it becomes a mess. Right? So I see I do have like terms in here. So that'll give me -12 plus 30I. And then I know that I squared is actually -1. So that's going to change that to a +12. So then what's my actual final answer there? Good, just 30I, because this is going to cancel with that. So just be careful watching those signs, because I know a lot of times, if you guys think back to homework problems that you've missed, how many of you just missed it because you missed a sign somewhere? Okay, so this is really easy to lose a sign. All right, how about the next one? Distributing 4 times -1. It's -4. 4 times -2I. It's -8I. 3I times -1. -3I. And 3I times -2I is -6I squared. I times I is I squared. All right, then we got to clean it up. In the middle, you have like terms. That's going to give you negative 11i. And then I know the I squared, that's going to become negative 1 inside there, which makes that positive 6. So then I have negative 4 plus 6, which is 2. And I have minus 11i. So common mistakes. I times I is I squared. Some people don't write that down. Another common mistake, instead of switching out the I squared for negative 1, they switch the sign and then leave the I squared there. And the other thing I see is people put negative 8i minus 3i, they put those like terms together. What do they think they do with their i's? Then they square them, and then they change the sign on it, and then it's way wrong. Okay, when do they become squared? Multiply. Adding them, remember we just putting things in a pile, right? 3 candy bars, 4 candy bars, 5 candy bars. They don't change candy bars. When I add them to my pile, they don't change, just when you multiply. All right, why don't you guys go ahead and do this last one for me. All right, let's see who was right and who was wrong. So distributing, 5 times 5 is 25. It gives me negative 15i plus 15i and negative 9i squared. What happens to your like terms? Those cancel. Those are opposites. So then I have 25 minus 9 times negative 1, which makes that plus 9. So 25 plus 9. Now everybody's doubting their basic math, aren't they? That's 34. Yeah, it should be 34. I did see more 34s than the other numbers, but I did see a lot of answers going on there. You multiplied wrong? Which multiplying did you do wrong? What did you say it was? You did 8? Oh, you add them. Okay, all right. So it wasn't that you don't know how to multiply, you just added instead. I thought you were going to tell me like 23 or something random. All right, those of you who messed up, do we see where the error came from? If not, please ask, because if you have a question, chances are somebody else does. Are you okay? So what do you notice, what happened to this answer compared to the other answers? What does this one not have? There's no i's left. I's are gone. The other two problems we did, there was still an I left in them. So what was different about this original problem? What? They canceled out, but what about the setup of the problem was different? They're opposites, yeah. You have a 5 plus 3i and a 5 minus 3i. So the first ones were an opposite. Those are both 5s. Just that sign in between was different, right? Those actually have a special name. Those are called complex conjugates. Okay, anytime you have something where there's one's plus and a one's a minus like that, they're considered conjugates or opposites of each other. Okay? So anytime you multiply those, hopefully you I would like you to recognize, like, hey, look, those are the similar, just different signs. Then your brain should think, I shouldn't have any i's left when I'm done. Okay? So just like this one, notice that's a negative 2, that's a negative 2. So when you're like, because I'm going to ask you to write conjugates for me, the first number doesn't change. The only part that changes is that middle sign. The sign in the middle is different. First number is the same, last number technically same, right? Just that middle sign is different. All right, but when you multiply them, negative 2 times negative 2, positive 4. Negative 2 times 7i is negative 14i. Negative 7i times negative 2 is a positive 14i. And then the negative 7i times 7i is negative 49i squared. Because what happens when you have opposites is those middle terms, those like terms right there, they're going to be opposites of each other then to cancel out. So we have 4 minus 49 times negative 1, which makes that 4 plus 49, which is 53. Thank you. Okay, so anytime you have those conjugates, those opposites, when you get all the way down to the bottom, there should be no I left over. Okay, it should cancel out. All right, so go ahead and give me the complex conjugate and then multiply them together. So if I gave you 4 minus 6i, what is its conjugate? Good, it'd be 4 plus 6i. The only part that changes is the sign in between. Bless you. Sounds like you guys are allergic to math today. Now, I will tell you right now, on your test on Wednesday, the 2 last questions look like this. Write the complex conjugate and then multiply. And you know what? I will bet you 75% of my students do. They just write the complex conjugate and then they don't multiply. Okay, so just kind of make that a mental note now, kind of tuck that away when you take that test Wednesday. I want you to multiply these two. The directions say multiply, like right in the directions. All right, so we multiply. 4 times 4 is 16. Multiplying there gives me 24i. Distributing the negative 6i gives me negative 24i. And then negative 6i times 6i is negative 36i squared. All right, like terms in the middle. Since they're conjugates, they should cancel each other out. So we get 16 minus 36 times negative 1, which makes that plus 36. So 16 plus 36 would be 52. All right, last one on your own. All right, so last one. I'm very happy to see that you guys, for the most part, did the conjugate right. It'll be negative 8 minus I. What do you think a lot of people try to do? That they miss that one. They change it to a positive 8, yeah. But that first one doesn't change, just that middle sign changes. So the first one stays the same. All right, so when you distribute, negative 8 times negative 8 is positive 64. Negative 8 and negative I make a positive 8i. Positive I, negative 8 is negative 8i. And then I times negative I is a negative I squared. Like terms in the middle, again, canceled out. I saw a couple people have a trouble here. They're like, yeah, I know I squared is negative 1. Some people multiplied. This is 64 minus negative 1, which really becomes what? Plus 1, which is 65. So just be careful. Saw a couple people actually ended up multiplying on accident there. Questions on multiplying. We know I squared equals negative 1. Do not ever leave an I squared on your paper. What else are you not allowed to leave on a paper in this chapter? Radical on the bottom. How about negative exponents? Can I leave those? No, can't leave those either. Can I leave perfect squares sitting underneath a radical? Can I leave pairs hiding underneath a radical? So lots of things to look for in this chapter.